Hi, I'm Mariam Abazarsa, a PhD student in a University of Massachusetts Lowell, and my research is about electromagnetic detection and identification of concrete crack in harbor bridge. As you know, infrastructure has a crucial role in human life. So, access and monitor this kind of a structure is necessary. And there are different ways to monitor the infrastructure. And these days. Non-destructive testing method is very popular among civil engineers. And I have to say that in our research, we use one of the high frequency non-destructive testing method to collect our data. We use the ground penetrating radar, GPR, to collect data for a long period of time. To assess the condition of a highway bridge. And at the first, I have to mention that we choose I-495, Chelmsford Bridge in Massachusetts, as a representative of highway bridges in New England to collect data. We use, as you can see in the picture, in a figure number 1, you can see that we use this GPR mini LT to scan to get the bridge columns and collect data. If I want to talk about our objective, I have to say that we want to collect a lot of data for a long period of time to assess the condition of the structure and obtain, and use the machine learning and artificial intelligence to create a pattern for material degradation, and use use pictures to create a virtual reality models. And you can see in the figure 1 the one of the column of the bridge that we can create a virtual reality 3D model of one of the concrete column with the with taking a picture. As I said before, we use the GPR to collect data, and the GPR works use from the electromagnetic waves to explore again image subsurface. And in the figure 2, you can see 3 columns that I put in my PowerPoint with the B scans that the B scans image that we obtain from the column in a different dates. It's a W8 column that we consider it as a intact surface. Because there's not any crack on the surface but we don't have any information about the inside of the column. But when you see if you see our B scans, but precisely you can see the hyperbolas in the B scans. In our B scans, that it's that actually these shapes creates because of the rebar that already inside the columns. Because when we scan the surface of the column, GPR send electromagnetic waves into the surface and they transmit or they get scatter or they get back of electromagnetic waves. And because of the rebar or has a high dielectric constant, so it's it's completely scattered or the back all of the electromagnetic that reach or to the rebar. And because it's electromagnetic waves reach to the rebar in different angles, it's created the hyperbola shape. And the peak of the hyperbola, we can already use the peak of hyperbola to to determine the location of the rebar. The location of the rebar. And and the next column, it's E4, column number E4, that we consider it as a moderate damage. And the besides of the picture of column, you can see the B scans, whether they get in a different dates. In this B scan, we can see the hyperbolas of the 2 that show, show the location of the rebars, but these were the images are not very clear, like W8, because because this surface of the column has cracked, bumped, and there are a lot of cluttering in our images. But if you if you see the surface of our image, you can see the hyperbola here, that these are the hyperbola that are near to the surface show the location of the cracks. It's show on the our cracks are that we cannot see on the surface, and there is a hyperbola that we can see here. And the last one is the 7A, that we consider it as a severely damaged picture, damaged, severely damaged columns that we can see the scans that obtain from this column, and you can see hyperbolas and like E4A, and the hyperbola that are in the surface of that we can consider in these part of the hyperbolas that are near to the surface of as a the location of the crack. And in the figure 3, you can see the you can see the the age kind of curves that in this part we decided to compare the B scans together. As I mentioned before, I said that the peak of the hyperbola show the location of the rebar, so we can obtain the scans that are in the location of the rebar and compare together. Compare them together, and as you can see in this curve, you can see in the location of the rebar, the amplitude of the scan signal comes down during the period of time, and during of time, and we can conclude that GPR scans, environmental situation can impact in our GPR scans, such as the temperature, moisture can impact in our B scans or images. And another thing that we can conclude from this comparison is about the rebars. We can use this scans and the B scan images to to assess the situation of steel rebars that are inside the inside the column. Because I mean about corrosion monitoring, because the rebar with corrosion, the amplitude of the rebar with corrosion is smaller than the the intact rebar. So we can use it to دیگه analyze or دیگه بسکن دیگه images و دیگه obtain دیگه more information. And in the future, دیگه we are going دیگه to collect دیگه more data and دیگه obtain دیگه more information to assess the condition of hardware دیگه bridge and use the machine learning and artificial intelligence to to create a pattern for a material degradation and to to find a way to create a crack detection.